Hello everyone, welcome to the Engineering Bart Show. Hope you guys enjoy my videos. Hope you guys enjoy that. I'm sure I did, but they're quite a challenge sometimes. So hit a like. Okay. Anyways, today's topic is we are going to have the embedded system count from 0 to 9 and then back again. We're going to use the common BCD LED and the common anode BCD LEDs. So if you could look closely, you might have to zoom in a bit. This is the configuration for common positive and common cathode. Know that these are just LEDs. That nothing has changed much, but how it's configured is going to be what you're looking for. So we need a count from 0 to 9, half-second delay. No additional chip required. No BCD drivers, nothing like that. You don't need anything else. All right, stop, build the code, build code for the project. These are for people that maybe want to challenge themselves, of course. They want to, maybe they already know how to do it. Go ahead. For other people that may not know or may not understand, go ahead. Let's continue on. Okay, so the new topic is called port out command. Port out command combines 8 ports as one object. So for an example, let's initiate. So port out, that's what we do on the code. My ports, that's port C, 0, XFF. Okay, so my port is an arbitrary name that I made up. So you can name whatever you want. You can call it my, his ports or your ports or just ports. You could call it whatever you want, or you could call it, I don't know. Port C, though, that identifies as we're using the port dash. I put star there. That means we're using 0 through 7. 0 through 7. 0FF is 8 ports are enabled from PCs 0 through 7. Okay. Now, we're going to use a hexadecimal system. This is just an example right here. You initialize it int my array 0x7c, 0x77, 05. That's just, you might not understand what that is right now, but we're going to get into it. So let's go to the whiteboard and explain into further detail. All right, hello everybody. So we're going to talk about we're going to do a refresher on the hexadecimal system, and for some people it may be a new experience. If it's a new experience, let me know in the comments, because this is where it's going to get a little bit more abstract. Okay, so as we know before, binary is 0, 0, 0. Decimal is 0, hexadecimal is 0. And then it goes to 1. That's binary for 1, 2, 3, and so on. 5, 6, 7, 8, and then, but as we progress in the nibble system, it's hard to put that 10 down. We can't put 10. Instead of putting 10, which is 1, 0, that looks like a 1, 0, which is confusing. It's going to be A. Okay, A is 10, B is 11, C is 12, D 3, and 14 is F. So converting from binary to decimal to hexadecimal in this part, and probably okay. So this is this second part of the lab, or of the experiment, or whatever. And what we're going to talk about is trying to configure the binary coded decimal to hexadecimal to when you put it in your code. This is very efficient. The code it will really help you guys out. Okay, so when we configure this, we know we want PC0 is going to equal A. PC1 equals B. PC, likes the D's. sometimes. PC D equals C, PC equals D, PC 4 equals E, PC 5 F, and PC 6 equals G. Okay, so that's so when we go to the AutoCAD section, I'm going to hook it up like that, and you'll understand. So that's hooked up to there, that's hooked up to B, that's hooked up to C, that's a D, and so on and so on. And that's supposed to be a G, not a 6. Okay, so like a G. Okay. Now we're going to introduce a term called port out. Port out is a very convenient thing on your code. We're going to call it BCD, port out C. Okay. There's going to be a counter, and it's going to count from 1 to 9, and then 0 to 9, and back to 0 again. Just going to count in 1 second intervals. Okay, so I'm only going to put a few of them here just to get the idea, and then we're going to get the Excel spreadsheet, and then we're going to do Excel spreadsheet on the code, and then what you do is you transfer your code that you made up to the real code that is on the real code section doing the Embed Studio. Okay, here we go. Okay. So we want 1. So we're going to have over here is going to be an int. Oh, I don't know. Numbers. Maybe that's, or num. I don't know. In that array equals, and then inside here. Okay, if you bear with me because I don't want to stretch. So inside here we need a 0. We need a 1, 2, 3, ... up to 9. Up to 9. So that's what we want. We want this to be here, and we want this to basically be into an array. So rather than adding chips, we're going to do the embed, or the microcontroller is going to do the work for us. Now, what does this mean right here? Port C. Port C, X, FF. What does that mean? Okay, yeah. Well, that is in a bytes system, and FF 1, 1, 1, 1, 1, 1, 1, 1 is FF. That is PC 0 through PC 7. We're not going to use PC 7. Okay? Okay. So, we need a 0. That's our first number. Our first number is, so we need A. Okay. So we need an A, which is a 1. So we're starting from left to right, not right to left. We're going this way. So we need an A, so it's going to light that up. That's PC 0. B, okay. C, okay. D, okay. Okay. And then put like a divider line, or that kind of helps out. Okay. Okay. A, B, C. A, B, C, D, E over here, F over here, and we don't use G, right? So there's G, and we don't use a decimal point. So the first number for 0 is 0x3 F. That's inside the array. Comma. Okay. So, all right, so we got that's going on. All right, so this is 0. That's 0. We're going to put a little comma. All right. So what's 1? What's 1? So let me go ahead and count it down. So to create a 1, usually it's these F and E, and then everything else is blank. Okay. So A is 0, B is 0, C is 0, D is 0, E is 1, F is 1, G is 0, and the other one is 0. So that would be 0, X, 3, 0. That's 1. Okay, let's do another one, and then we'll go to and then we'll talk about exclusively common anode. Exclusively here. Okay, let's do 2. Let's do 2. So all we're doing is following the shape. Okay, so we'll do one more, and then you guys can figure it out on your own, or kind of watch me do it on the next section. I highly recommend you guys do it yourself, because if I do it, then it's not, you're not doing it, you're not learning anything, you know what I mean? So, okay, let's do 2, and then we'll talk about common anode. So 2 has sort of a shape of, how does it go? Okay, so that's one right here, that's one right here, that's one right here, that's one right here. I think that's a 2, right? So we're following the shape. And you know, to tell you the truth, if you know how to do this, you could probably work for the Department of Transportation that says, you know, don't drink and drive. It's sort of the same thing. So let's go ahead and erase this. Let's go ahead and erase this. And now we're going to put 2. And remember, this is ground, this is a sourcing, okay? And when it's sourcing, it's coming from the embed to the LED, and then it grounds out. That's common cathode, okay? And you can see that if you have one, you got to go to your data sheet if you have a common cathode. Now, let's do 2. All right, here we go. So 2 is, well, let's think. We got A, well, that's a 1. B, 0. C is 0. D is 1. Okay, D is 1. E, I think that's a, yeah, E is 1. F is 0. And G is 1, and of course there's a 0, okay? So that's going to be 9, which is A, okay? 9 is A, and that is basically 5, and that's a 5. So now it's a 0x5A. So you guys can continue on with the rest of the stuff. All right, bear with me. No. Bear with me, we're going to do common anode, which is exclusively here on the Engineering Bard Show. It's hard to find this literature. Here we go.
All right, here we are, back on the AutoCAD section. So we need 7 resistors. Here's my BCD. Hope you guys can all see that. Okay, let's kind of set everything up. Okay. Let's kind of move that over here. So it looks like it's a bit square. Okay, that's over there. All right. Okay. Let's start wiring this thing up. Okay, I like the old ortho wire. What we want is the electrical. We want it. Okay. And where does this go? That's right, PC0. Okay. All right, we're going to hook up the next one. Okay. Okay, zoom that out. A, B, there's C. Now that's the decimal point. We don't hook that up. That's why that one number is either 0 or 1. So that's what so that never gets hooked up. If it does get hooked up, then we have to take that into an account. And so that's if you want to do, I don't know, maybe you're doing a more of a precision scale or something like that. You know, something like that. I don't know. A, B, C, D, K. All right. E. Hope you guys can see that. I try to do it as clear as I can. So now this has to be hooked up exactly. You can't skip anything because it's the ports are going where they're supposed to go. If you put it elsewhere, let's say you put it in the wrong port, all bets are off. Oops, did I? Darn it. Oh, that's bad. Oh, crap. Did I? Ah, shoot. Don't want to do that. It's gonna short it to ground. It's bad, Andrew. Bad, Andrew. A, B, okay. We have to do it over here. Gotta hook up to a resistor. It's just, I don't want to say anything that's give you guys ideas. I mean, it's better to be safe than sorry, you know what I mean? So, especially when it comes to hooking this up. Okay, A, B, C, there's D. Don't forget the resistor. We're going to hook it up to the resistor. Oops. Okay. Okay. Let me see if I can aim it a little bit better. And fire. Okay. All right. Okay, we're cruising, folks. We're cruising with, ooh, I don't want to do that now. That's going to make things confusing. There you go. Get out to here. There's PC4s right here. Click. Enter. Let's go ahead and delete that. E. Yep, EFG. That's right. Okay. And then F. Right here. It's getting a little bit convoluted, but we're gonna make sure that it'll be squared straight. On the breadboard, as you guys hook this up on the breadboard, it can be kind of tricky. So it's a little bit more challenging to hook it up physically than to hook it up. Oops. Okay. All right, we're just gonna kind of. It's like Tron, you know. Okay, enter. 4, 5, 6. Okay, that has to be a 7. It can't be an 8. So yeah, you want to cheat and go to 8, but no, it won't let you. Otherwise, it won't turn on. So that's part of the deal. So it has to be. You have to put it there. Okay. Now we got to hook up the grounds. Okay, let's go ahead and copy this. Okay. All right. Oops. Let me. Oh no. Oops. I'm gonna turn ortho off. Just went. Okay. That's pretty good right there. Okay, move. For some reason, there's 2 grounds. Okay, we're just going to put that over there for right now. I'm going to put this way over here just to isolate it just a little bit. Okay. Okay. Okay, let me get the wire out here. Okay, let me get back ortho. Okay. It's hard to think and talk at the same time. That's because I'm in deep thought. Let me see if I can connect that a bit better. Okay. Well, you guys will know. We'll put a note on it. Okay. Click. Okay. Okay. And of course the board has to be grounded. So that's pretty much it. I'm gonna put some nodes on here real quick. Okay, so we got everything all hooked up. We got the nodes all hooked up. We got everything all hooked up. Now we just got to put in the finishing touches, which is we're going to look it over. Looks pretty good. Now we got everything correct. I think I made a mistake. It's PC 0 through 6, so it's not that bad. You don't need 7. So let's go ahead and let's fill in all the holes. Fill in the ground. And PC 2, 1, 3, 0. PC 4. PC 5, PC 6. So that's pretty much what a common cathode should look like. Let's kind of clean this up a little bit. Okay, look, this looks good. Okay, everything's grounded. That's grounded. Okay. Okay, let's delete that there. Okay. And that looks good. Okay, so now we're off to the anode, the common anode. So we got to take these grounds out. We got the battery there. Okay, take these grounds out. We don't need these. And the ground right there, instead of making a whole new set, it's the same thing, except it'll say like VCC. So just kind of pretend it says VCC. You just got to use your imagination. Okay, hook that up. Okay, let's erase this right here. Okay, I'll connect it to one part. Okay. Just move this around. Clean up all these dots. Yep, there we go. Take them all out. And okay. Gonna put a line from the ground to the bottom of the battery right there. Okay, now let's just fill it in. Let's make that a little bit more tighter. Okay. Okay, let's grab this node right here. All right, let's try to find it. Oh, that's it. That's a hatch. That's right. That's what I'm looking for. Okay, just fill it in. That should be it. Let's just clean it up. Okay, delete. And delete. Okay. All right, let's see how this thing works. I'll see you at the pre-code section. All right, so here we are at the pre-code section, and this is the common anode. So I set everything to 0 here, and let's go ahead and follow this. It's not as hard as you might think it is. So when we do the code, we're going to go A, B, C, D, E, F, G, just like we're following the alphabet. So our 0 is 1. That's going to be on. B is going to be on. C is going to be on. D is going to be on. E is going to be on. F is going to be on. But G and decimal point are going to be off. You got to put the decimal point in there, by the way, so even though you don't use it. Okay, so now let's do 1. So the only thing that's going to be on is F and E. F and E, so, all right, we'll put a 1 here, put a 1 here. Okay, all right. So I'm just going to put in all the ones, and then we could do the calculations a bit later. Number 2. So A is on, B is on, C is off, D is on, E is on, F is off, and G is on. Okay. All right. So then 3 is, so 3 has that shape, kind of follow A, B. Is it 3? Yeah. A, B, G is kind of that shape. See, kind of like follow the cursor there. Okay. So A is on. B is on. C is on. D is on. E is off. E is off. F is off. And G is on. And we're going to continue on. So what do you guys think the 4 is? Kind of. So I'm just going to go ahead and do it. So let's just kind of do it without me saying. Okay, so 4. Okay, that's 4. What's 5? Well, 5. I'm gonna gotta visualize it a bit. Sometimes. Okay, so the only thing that is not on is E and B. Okay, decimal point is always off. Okay. All right, let's go ahead and do 6. Do you guys put the... Yeah, okay, so 6, I do believe only B is off. Seven. I think A, B, C are on, and that's it. 8. Well, everybody should know 8. We're going to turn everything on. That's a nice one right there. That's easy money right there. It's pretty gravy. And now 9. 9. Does 9 have a... Yeah, 9 has... Okay. So 9, I think it looks better if E and D are off. right, so now we got everything down. Let's do the calculations. So when we do the calculations, we go from left to right, starting with the decimal point. So the first calculations you want to put into binary is 0, 0, 1, 1, 1, 1, 1, 1. Make sure there's 8. So now we convert the binary to hexadecimal, and it should be 3F. So why don't you guys go ahead and do that while I type in the numbers. So the second one I do believe is 30. Okay. I know. It's exciting. I know. 30. Okay. Okay, here we go. Number 2. Okay, I believe it's 4F. I think it's 6, 6. Okay. Number 5 should be kind of a high number. Oops. 6D. Number 6. $70. Now, if I make a mistake, there's going to be some troubleshooting. So that's okay. I have to check over my notes. It's easy to make a mistake. That's 7 right there. 7 is 7. That's pretty easy to remember. There's 8. 7F. Okay. Last one is number 9. I'm gonna double check my work though. Zero 6 7. Let me see. Okay. Okay, so we had to do. Okay, so we had to do a little bit of corrections there. The number 1 is 0x06. That's because I put it on F and G instead of B. It all depends on your perspective, you know. Okay, now before we answer the question is what do we know about common anode? Common anode is we put the VCC, the 3 volts, in, and now it has to accept. Okay, so as it accept, is the code going to be the same? Well, it's actually not the same. Okay, so all right, so this is the common anode section. It's not A. Okay, so that means when it's off, it's a 1. And when it's on, it's a 0. So let's go ahead, and so that means the decimal point, these all are going to be 1s. Let's just go ahead and do it. Okay, so everything's going to be 1s. So everything is the same, except now we have to calculate it with zeros. So the only thing that has a 1 on 0 is G. Okay. Okay. Let's go ahead and this time let's just calculate it out. Okay. C0. Okay. All right, now let's do number 1. I guess we're going to do the same thing. So BC are the only ones that are zeros. Okay. That means everything else is a 1. Okay, it's going to be F something. It's going to be like F9, I think. Let's see. There you go, F9. Just want to confirm it. All right. And so everyone, you can just go ahead and do it yourself, and I will calculate this stuff out. Okay. A4. That's what I got. Number 3. Okay. All right, so let's go and calculate that out. It should be like B0, I think. Yep. All right. Number 4 is number 4. Number 4 is A, E, and D. I think that's going to be 99. I'm pretty sure. Yeah. Let's do number 5. Okay, E and B. That's going to be 91, I think. Let's go check that one out. That was a bit weird. '92. 92. I was off by 1. And if you're off by 1, it just won't look right. So. Mm-hmm. 6. Okay. I think B is it right there. B is the culprit. So B is the 1. That's going to be 82, I believe. '82, that's right. Let's do number 7. Okay, we're almost done. Almost done. So number 7 is ABC. ABC. Okay, ABC. Okay, everything else is 1s. Okay. That's definitely going to be F8, I do believe. F8. So sometimes I like to be super confident, but sometimes I need a calculation device to make sure that kind of helps me out, but I'm pretty sure it's F8. Okay, number 8. Number 8, oh, that's a good one. That means they're all 1s. No, they're all 0s, excuse me. I almost mucked that one up. That means they're all 1s. 7, that means they're all 0s. So that's going to be 9, 8, excuse me, 8, 0. And 9, of course, is E and D are 1s. Okay, and that's going to be 98, I believe. 98. Yeah, 98. Okay, so here we are. We're here at the IDE, the Embed Studio. We're going to go to Embed Program. We're going to call it. What should we call it? Maybe we should call it BCD. BCD anode and cathode. There you go. That's something that you can remember. Let's add the program. Okay, there it goes. Getting the libraries, all that good stuff. Let's write down a description. It'll be a little quick description. I know people are impatient, but we're going to have to do what we have to do. Okay, this code is a section for BCD. I'm kind of a slow typer if you haven't noticed. Counting from not 2 to 0 to 9 in 1 second intervals. Okay, using only embed. Just basically the little device that I have. 5/31/2025, and we're going to put my name, aka Engineering Bard. All right. Okay, here we go. So first thing we got to do is hit the return key. Okay, and we're going to port out. Remember, port out my port. Ports, I guess. Port C. Is it underscore C? No. 0xFF. Wait, something's wrong there. That's it, port C. Okay. Semicolon. Okay. And then we're going to put the numbers inside an array. Int LEDs, those little square brackets, equals. And then the code, they should get everything from the pre-code section. So let's put in for the common cathode section. Okay, just type it in. Now, if you haven't gone to see the pre-code section, I highly recommend you see it, because it's you won't know what these things mean. Okay, 6.6, and then I think it's OX60, 6D, 7D, and 707. And I think we're on 8, which is 07F, and then 9067. Okay, we're also going to put in the code for the common anode. So I'm going to say CC common common cathode. All right. "9:26 a.m. What the hell?" Oh, anyways. Oh yeah, that's what time it is. Yeah, this is for the common anode. I grab my papers around here somewhere. Ah, there it is. I found it. Okay, 0C0. F9. Zero 099. Let me see, 192. 092. Yeah, for some reason, I guess it's not case sensitive. So a lowercase f and an uppercase f is exactly the same thing. So I mean, when it comes to BCD, and when it comes to identifying other stuff, yeah, then it's completely different when it comes to. But to comment it out, so when you uncomment that out, that's going to be the common anode code. Then you have to comment the common cathode. So when you comment, as you guys know, it's the compiler will ignore that. It's going to be like, no, I don't know what. Actually, it just won't see it. So it just ignores it. Define time. Okay. And this is only has maybe 5 lines of code, I think. It's pretty short. So int counter. We have to have a counter. Counter equals 0. Okay. Let's go on the next one. Inside the super while loop, we got to put my ports equals LED. Inside the array, we got to put the counter. When it counts, it's going to put it to the ports. So when it counts to 1, the port's going to say is going to read that. I mean 0. Yeah, 1's over here, obviously. And then we're going to put time. Then we got to put an if statement, or then we've got to count plus plus. Excuse me, count plus plus. Then after that, put an if statement because they'll keep counting and won't stop. Count counter equals 10. Then we want to set the counter to 0. And that is all this. That's it. It's pretty short. I like it. It does quite a cool stuff. All right, let's see. Let's go to the proof section. Thank you. Bye. Well, there you guys have it. That's a common cathode. Yes, common cathode. And so let's go ahead and check out the common anode section. See, 4, 5, 7, 9, back to 0. Okay.
All right, so there you guys have it. This is the common anode. How can you tell? Let me go ahead and just move the camera up just a little bit. There's my battery. It's on at 3.2 volts. And it's counting down just like the common cathode. So, thank you. Thank you for watching. And please don't forget to subscribe. And I'll see you on the next Engineering Bard Show.